Good evening, guys. My topic tonight will be evaluation of definite integrals. It's another problem. The last time around, I give you one example on the evaluation of definite integrals. Tonight, I will give you another a little bit complicated problem. Okay, let's proceed. Definite integrals, we are asked to evaluate the value. Evaluate the value of the integral with the limit from 0 to pi over 4 cosine of square root of x dx equal to. We are asked to evaluate the value of this if the lower limit is 0 and the upper limit is pi over 4. Obviously, the equation is actually a trigonometric equation. Guys, this is lesson number 44, Integral Calculus under my channel. Topic, Integral Calculus, lesson number 44. We are now through with differential calculus, the complete course. Okay, let's bring out the solution. The solution will be something like this. Using algebraic substitution, it's not trigonometric. We let y. The complicated term on the given problem is this is square root of x. So we'll try to simplify this one by using algebraic substitution. So we let y equal to square root of x. Okay? Squaring both sides. Okay, y to the second power will be y square. Square root of x to the second power will be x. It is actually x raised to 1/2. Square root of x is x raised to 1/2, right? Then square that again. Okay, this two here cancel with this. So the resulting exponent of x will just be simply 1 times 1 over 1 or 1 or just simply x. So after the squaring, y square will be equal to x. Okay? Take the differential of both sides to bring out the x in terms of y. The differential of y square is 2y dy equal to the differential of the right hand side is just simply dx, or dx, if we will try to rewrite it, dx is equal to 2y dy, right? Let's go back to the original problem. The integral of 0 to pi over 4 of cosine square root of x dx equal to the integral from 0 to pi over 4. Okay, let's replace all x by y. So this should be cosine of square root of x, but square root of x is y, so this should be y. Times the value of dx, but the value of dx is 2y dy. So what will come out is actually, we got it 2 here. Okay guys, we bring it out to the integral from 0 to pi over 4 of y. I write this one ahead because the angle on the cosine is y, so they will not interact illegally, okay? So the integral from 0 to pi over 4 of y, cosine of y dy. Okay? We cannot integrate yet this one here. So by using our knowledge of any kind of integration that you could think that will solve this one, I think this falls under the integral of UDB. You recall the so-called integration by parts? That the integral of UDB is equal to UB minus the integral of b du. So the meaning of this formula here, for us to integrate this one, we must have to compute for the value of u and for the value of b minus the integral of b du. Okay, let's bring out our substitution. No, not substitution. Let's bring out the value of u. And let u is equal to y. Taking the differential of both sides, u will be dy. Okay? So, if u is y, db will be cosine of y dy. db will be cosine of y dy, right? We are following this. Therefore, integrating both sides, the integral of dv equal to the integral of cosine of y dy. B now will be equal to the integral of cosine is sine y. Because if you take the differential of sine, it will be cosine. That's the answer, right? So the integral of cosine of y is just sine of y. Okay? Rewriting the original problem. Therefore, the integral of 0 to pi over 4 of cosine of x, square root of x dx equal to, we are following this, okay, because we solved this one by integration by parts, so this should be 2, integration by parts, ub minus the integral of b du with the limit from 0 to pi over 4, okay, this should be 2, okay, what is u? U is y, and what is b? It is sine of y. This is actually ub. And this is b du. Right? So 2, open quantity, y sine of y, minus, this is now integrable. The integral of sine is minus cosine. Okay? So minus open quantity, minus cosine of y, close quantity with the limit from 0 to pi over 4. Simplifying, this should be 2, y sine of y, minus minus will be plus, cosine of y, with the limit from 0 to pi over 4. Actually, this 0 to pi over 4 is actually x. Our final answer is actually in terms of y, so we must have to bring back, replace y by its equivalent of x, okay? Because this limit is actually x abscissas, it's not ordinates, okay? And where do we get the relation? It's from the original relation. Therefore, 2, open bracket, y is actually the square root of x. Square root of x, sine of y. What is y? Also is square root of x. Plus cosine of square root of x with the limit. Actually, these limits are actually x equal to 0, x equal to pi over 4 for the upper limit. Okay, we are now given the final answer in terms of x, and our limits are actually x equal to 0 to pi over 4. Right? It's just a matter of substitution now, guys. Okay. Before I will substitute the value, I will try to illustrate first. 2 pi, one complete circle is 360 degrees. We divide both sides by 8. 2 pi over 8 will be 360 over 8. Why I want pi over 8? It's pi over 4. Because I want to get the value of pi over 4. Right? Because our upper limit is pi over 4. And I want to get the equivalent of that in terms of degrees, and that is actually 45 degrees. Is it correct? 45 times 8. Yeah, 360. We divide 360 by 8, that will be 45 degrees. So meaning, so you don't be misled with the value pi over 4. How big is that one? 45 degrees? 45 degrees is something like that. This should be 1, and this one, it's 45 degrees, right? So pi over 4 is actually 45 degrees. And I want to compute for the value of square root of pi over 4. The value of the determined side should be radians. You cannot take the square root of a degree, okay? It should be radians. So the square root of pi over 4 will be, pi over 4 is 0.7853. Take the square root of the 1. Okay? It will be 0.866 radians. How many degrees will be that one? I'll just convert it times 360 degrees over 2 pi radians. Okay? Radians cancel. So, after multiplying by 360 over 2 pi, the unit of the square root of this pi over 4 will be 50.77 degrees. This will be the one you will substitute here. Okay? Okay? So, you don't commit mistakes. So, simplifying this one, they should be 2. Pi over 4, take the square root, that's 0.866. Sine of 50.77 is 0.774 plus cosine of 50.77, this is 0.632 minus the value of the lower limit. The lower limit will be this. It will become square root of 0, sine of the square root of 0, plus cosine of square root of 0. We are following this. We just substitute the upper limit. This is the value. We substitute the lower limit. This will be the value. For the lower limit, it will be easy now because square root of 0 is 0. Square root of 0 is still 0. And the sine of 0 is still sine of 0. What will be sine of 0? It's 0. Okay? Plus cosine of 0, that will be 1. Okay? What will be sine of 0, guys? 0. 0 degrees sine. It's 0. Okay? So actually, this will become 0. This will become now. So what will come out on the lower limit after the substitution, it will just be simply minus 2 times 1. This is minus 2. We combine this one, it is 1.32. So the final answer will be 2 times 1.32 minus 2. This is 0.64. So the answer is actually 0.64, approximately. Meaning, if we try to evaluate the integral with the limit from 0 to pi over 4 of the square root of cosine of x, square root of x dx, and this should be equal to 0.64. Why am I bringing out a number now, guys? We are on definite integrals. So after the substitution of the lower limit and upper limit, there will be an answer. Okay? It should be a pure constant. Okay? So the final answer is 0.64. That's it, guys. We can solve this one by the help of a calculator. Okay? Because you don't memorize the sine and cosine value of 50.77 degrees. Even if you use your trigonometric table, this will not be exact because it got a 0.77. So actually, you must have to use a scientific calculator. Later on in the evaluation of problems, we need our calculator. Okay? Okay? Like in civil engineering and the so-called timber design, upon the substitution of all the values, okay, you will compute maybe the modulus of elasticity maybe, or the width and depth of a timber in which a civil engineer is designing. Actually, it is something like similar to this, you know. You substitute values and the final answer should be a pure constant number. That's mathematics, guys. That's engineering. Okay, good evening, Los Angeles.